Hello students, myself Sudipto Karmakar, Assistant Professor of Physics, Department of Basic Science and Humanities, Swami Vivekananda Institute of Science and Technology. In today's class, we will solve a problem related to simple harmonic motion that came in MAKAUT semester exam or semester 2018-19. The question is, the motion of a particle in simple harmonic motion in SHM is given by y equals to a sin omega t. If it has speed u when displacement is y1 and speed v when displacement is y2, then show that the amplitude of motion a equals to v square y1 square minus u square y2 square divided by v square minus u square whole to the power half. So let's solve this problem. First of all, the equation is given y equals to a sin omega t. Using this equation, we will first find the expression for the velocity of the particle. Now, since it is the displacement of the particle executing simple harmonic motion, then to find the velocity of the particle, we will differentiate y with respect to time. So, the velocity of the particle v equals to dy dt, which is the first order time derivative, and since a, it is the amplitude of the particle, or it is the amplitude of the motion, so therefore y equals to a sin omega t. Now first of all, we want to find the expression for velocity of the particle executing simple harmonic motion. Therefore the velocity is the first order time derivative of the displacement of the particle, that is velocity v equals to dy dt. It is equals to a dt sin omega t. So if we take first order derivative of sine function, we will get cos function, and the constant and omega in this case is a constant. So here after the derivative is complete, we have a omega cos omega t, and cos omega t is nothing but root under 1 minus sine square omega t. So I am writing it in the next line, a omega root over 1 minus sine square omega t. So we have v, the velocity of the particle, equals to a omega root under 1 minus sine square omega t. Since cos omega t is equals to 1 minus sine square omega t. In the next line, I am substituting the value of sine omega t from this equation. Y equals to a sin omega t, therefore sine omega t is equals to y by a. I am just putting y by a in the position of sine omega t. So we have v, that is the velocity of the particle, is equals to a omega root under 1 minus y by a whole square. Therefore velocity v becomes, after some simplifications, velocity v becomes, it is equals to omega root under a square minus y square, where v is the velocity of the particle, omega is the angular frequency of oscillation, a is the amplitude, and y is the displacement of the particle. Fine. Now according to the question, the particle's velocity is u when its displacement is y1. So if we put these particular values in equation 1, then we get, in the place of v, that is in the place of velocity v, I am writing u, and in the position of y, I am writing y1. Since the particle has velocity u when the displacement of the particle is y1. So initially the velocity of the particle in such case becomes u equals to omega root under a square minus y1 square. Now if we take squares both sides, then we get u square equals to omega square into a square minus y1 square. This is our equation number 2. And in the second case of the given problem, the particle's velocity is v. The particle's velocity is v. Mind it that the velocity, the general expression of velocity, I am writing it by italic v, and the particular value of the, in the second case of the velocity, I am writing it by capital V. And the corresponding displacement is y2. So from equation 1 we get V equals to omega root under a square minus y2 square. After taking squares both sides, we have V square equals to omega square into a square minus y2 square. This is our equation number 3. Now if we divide equation 2 by equation 3, we get u square by v square equals to omega square a square minus y1 square divided by omega square a square minus y2 square. Now omega square cancels out, so we have u square by v square equals to a square minus y1 square by a square minus y2 square. Now if we cross multiply, then we have u square into a square minus y2 square equals to v square into a square minus y1 square. Now I am multiplying u square with a square and y2 square, so we get u square a square minus u square y2 square equals to v square into a square, that is v square a square, minus v square into y1 square, that is v square y1 square. Now if we just rearrange the terms together, so we have v square y1 square minus u square y2 square, and all the terms that are related to a square, I am just writing them on the right hand side. So we have v square a square minus u square a square. Now I am writing left hand side in the right. Now I am writing right hand side in the left and left hand side in the right. So if we take a square common, we get a square into v square minus u square equals to v square y1 square minus u square y2 square. Therefore a square becomes v square y1 square minus u square y2 square divided by v square minus u square. So if we take square root on both sides, we get a equals to v square y1 square minus u square y2 square divided by v square minus u square whole to the power half. So this was the proof, and hence the problem is solved. Thank you.